Hello, ladies and gentlemen. Welcome back to day 2 of chapter 6.1 on probability and simulation, the study of randomness. Now, I'm going to do some more examples of simulating some problems. Remember what simulation is: the imitation of chance behavior based on a model that accurately reflects the phenomenon under consideration is called simulation. Now, before I go any further, I want to pull in Schoology, and I want you to stop this video if you have not watched the day 2 against all odds probability models. Please watch that first, and the against all odds random variables. Okay, so if you haven't watched those yet, please stop and watch those 2 videos now. Okay, they're short. All right, now that you are back, ladies and gentlemen, let us look at the examples. First one, working women. Assume that the percentage of women in the labor force of a certain country is 30%. Okay, a country, 30%. A company employs 10 workers, 2 of whom are women. Seed the calculator with 500. Okay, so we're going to use the calculator to simulate this one. Now, I'm not going to go through step 1, step 2, step 3, step 4. What I'm going to do, I'm going to jump and I'm going to go to the following. All right. So, first of all, I'm going to define the digits. Okay, you always need to define your digits. So now let me make that a little bit smaller. Let's go there. That's good enough. So, ladies and gentlemen, what I'm going to do is I'm going to use 0, 1, 2 for women and 3 to 9 for men. All right. And when I simulate this, I'm going to look at 10 digits to simulate the 10 workers. All right, I do need to at least write that part down. Now, let me add one more thing to this. I am going to do 25 repetitions. Okay, I'm going to do 25 repetitions. Now, I'm not going to go through every single repetition with you in this video. I'm going to get it started, and then I would like you to finish it and see if you get the same result that I got. All right, so here we go. So I'm going to go ahead and go to the calculator. Okay, I'm going to seed it with 500. So remember how this works. I'm going to go to 500. I'm going to hit the store button, the math button, go to probability, and pick number 1. So everybody should be getting the same answers. Okay, so technically this is really not random, but we're going to make believe it is. All right, so we've got that seeded. Now we're going to go to the math button again. We're going to go to probability, and we're going to pick number 5. Now, since I'm using 0 through 9, okay, 0 through 9, I'm going to go ahead and put 0, comma, 9, comma, 10. Okay, so it's going to randomly pick 0 through 9, and it's going to pick 10 at a time. 10 at a time. All right, so I'm going to hit enter. Now, when I count this, ladies and gentlemen, I find when I go through, now I'm going to have to use my arrow key. When I go through, I notice, ladies and gentlemen, there's only one woman in that simulation. All right, so what I'm going to need to do is I'm going to need to write down, okay, 1. Okay, that was my first one. All right, now you don't have to, all you have to do is hit enter for the next one, enter. Okay, now when I count this one, I look for 0, 1, 2. I look for 0, 1, 2. I notice that there are just 2 women. Okay, so I'm going to write that down, 2 women. Okay, I'm going to simulate one more time. I'm going to hit, well, I'll simulate 2 more times. I'll hit enter. Okay, now I'm going to, again, I have to use my arrow key. I'm going to count 1, 2, 3, 4, 5. That simulation gives me 5 women out of 10 in that company. Okay, again, I'm just going to hit enter. And this time I count them up. There are two women in that company. Okay, one more time. Again, all I have to do is hit enter and count them up. And I find out that that company has 4 women. All right, ladies and gentlemen, pause the video right now and do 20 more of those and see if you come up with what I get. Now, there's a very good possibility I might goof, so you may disagree with me, but hopefully I didn't goof when I did it, okay? All right, so pause the video now, and I'll be right back. All right, I'm back. So this is what I came up with for the 25 repetitions. All right, so now the question is, let me go back to the question. What is the probability that this would occur by chance? Well, the question is 2 of whom are women. So I notice, ladies and gentlemen, that there are 3 of them where there are 2 women in the company. So 3 out of 25, that ends up being 12%. So there's a 12% chance that 3 out of 25 times that there's 2 women in that company. Now, B, based on the simulation, estimate the probability that a company of 10 workers would employ 2 or fewer women. Okay, 2 or fewer. So part B, okay, part B, 2 or fewer. Well, if I count all of them, okay, so 2, let's see, 1, 2, 3, 4, let's see, 5. That's all I see. So 5 out of 25 times there were 2 or fewer, which is 20%. All right, what does C say? Estimate the expected average number of women that a company of 10 workers would employ. Oh, the average. Okay, so folks, I'm going to add them all up. And divide by 25. Okay, because it's the average. Well, let's see. If I add them all up, and hopefully I did my addition correctly. If I add those all up, I believe this is what I got. I got 91. And 91 divided by 25 is 3.64. Well, you know, we can't have part of a woman, right? Okay, you can't have part of a person. So what I'm going to say is 3 to 4 women. Okay, it's closer to 4, but we'll just say 3 to 4 women is the average. All right, and then part D, ladies and gentlemen. Part D says, all right, well, on the basis of the simulation, do you think that women are underrepresented in the company? Why or why not? Okay, well, you know, the average is 3 to 4 women. But 2 women being in the company is not really that far off. I know we got 12% in our simulation, but you know, okay, think logically here, okay, really 2 is not that far from 3, okay? So I would say no. Okay, you may argue with me, that's fine. Okay, but this is what I'm going to say. Even though the average is 3 to 4 women, having 2 is not that far below the average. So even though the average is 3 to 4 women, having 2 is not that far below average. Having only 2 women is not unusual. Okay, I don't think that is. Now, if the average was 5 or 6 women, then I think I would change my mind. Okay, but 3 to 4 and you have 2, that's so close, so close. All right, okay, let's move on to the next one. Traffic lights. Coming to school each day, Martina never turn over. Now, I don't know if any of you know about golf. Now, there was a famous, not golf, tennis. There was a famous tennis player. Her name was Martina Navratilova. Okay, so one of my math buddies down in Texas came up with Martina never turn over. All right, she rides through 3 traffic lights, A, B, and C. The probability that any one light is green is 0.42. Use simulation to answer the questions. Use the calculator, seed the calculator with 180. All right, so A, what will the digits represent? Okay, well, since we're using the calculator, now I'm going to do both here, okay? So if we're using the calculator, ladies and gentlemen, so this is part A. So if using the calculator, okay, we will let 1 through 42 represent green, and 43 through 100 represent red. But now, let me switch colors here. That didn't switch colors on me. Switch colors, come on. If we use the random digit table, then 0, 1 through 42. Notice I'm using 2 digits. 0, 1 through 42 will represent green, and 43 through 99 and 0, 0. Okay, you have to have an even 100 numbers here. 43 through 99 and 0, 0 will represent red. All right, so again, if I'm using the random digit table, okay, I want to use every 2 digits. So you have to have that 0, 0 in there. I don't want to use 0, 1 through 100 because that 100 is a 3-digit number if I'm using my table. But if we're using the calculator, we don't need to worry about the number of digits that represent something. Okay, so that's part A. Part B, estimate by means of a simulation the probability that Martina will find all traffic lights to be green when she drives through in the morning. Okay, so part B, ladies and gentlemen. So what I'm going to do is I'm going to say one trial will be 3 numbers. And I'm just going to do what it says. I'm just going to do 10. Now, really, that should be 10 repetitions. Okay, not trials. One trial will be 3 numbers, and I'm going to do 10 repetitions. So ignore the do 10 trials. Okay, that should be do 10 repetitions. Now, when I do this one, ladies and gentlemen, okay, so let me get the calculator set up. So again, we're going to seed the calculator with 180. All right, so let me get this rolling here. So I'm going to go ahead and put in my 180. I'm going to hit store. I'm going to go to probability and pick rand. All right, I'm going to go back to my probability, number 5. So I'm going to go ahead now, since I'm using the calculator, I'm just going to go ahead and go 1, 100, 3, because it's 3 traffic lights. Okay. So when I write this down, I need to write down what it means. So this would be green, green, red. Okay, and you actually need to keep track of that as you're going here. All right, let me get my pen going here. So I'm gonna write down green, green, red. So that's the first trial. All right. Now just hit enter. Red, red, green. Okay. Red, red, green, and you might want to keep those separate. Okay, so you don't get them mixed in. Okay, I'll show you 2 more of these, and then I'm going to stop and finish it, and then hopefully you will have the same thing. So now this one would be red, red, red. Okay, so I'm going to write that down. Red, red, red. So there's my 3rd trial, okay, or my 3rd repetition. 3rd repetition. Okay, I'm going to do one more, and then I'm going to stop it and finish it, and then you pause it and you finish it. Red, red, red. Okay, so let me get that written down. Red, red, red. Okay, you go ahead and pause, finish it. Hopefully yours will match mine, and hopefully I didn't mess up as I did it. All right, so I'm going to pause and finish. Okay, so according to that simulation, I came up with 1. So the question is, all of them are green. So in those 10, I came up with 1 out of 10, or 10%. So 10, according to that simulation, 10% of the time, all of them are green. Now, if you're using the random digit table, again, on the AP test, they're probably going to have you do the random digit table. So on the random digit table, you would have to look at every 2 digits, and then you'd have to go, so this one would be green, green, green. So if you were using line 101, we would right away have 3 greens in a row, okay, because you got to look at every 2 digits. All right, but we use the calculator. So let's look at the next one, part C. Okay, and it's not going to let me go up, so I'm going to have to drag this down just a second. There we go. Now let me do this, and it should be fixed. All right, so let's see. Part C says, well, that's strange. I don't know what it's doing here. Estimate the probability that Martina will find at least 1 light to be not green. Okay, well, not green. So part C, if you look, at least 1 not to be green, that means 1 or more, right? Well, that's the rest of them, folks. That's 9 out of 10, which is 90%. All right, let's keep rolling here. Game of chance. A game of chance is based on spinning a 1 through 10 spinner like the one shown 2 times in succession. Well, I didn't show it, folks, but okay, it's a spinner with 1 through 10 on it. Okay, you know what a spinner is. Ooh, that is a bad drawing here. So I've got a spinner with 10 spaces in it. Okay, that's not going to be 10, but you got 1, 2, 3, all the way to 10. Okay, so ignore my drawing, it's horrible, but imagine a spinner. So the player wins if the larger of the two numbers is greater than 5. Use the calculator seated at 205. Okay, so it says, well, what constitutes a single play of this game? Okay, well, A, that would be 2 spins. 2 spins is a single play of the game. B, what are possible outcomes resulting in a win? Ooh, okay. Well, let's see. 1-1, 1-2, 1-3, 1-4, 1-5. Okay, that's a possibility. 2-1, 2-2, 2-3, 2-4, 2-5. 3-1, 3-2, 3-3, 3-4, 3-5. Again, anything 5 or less. 4-1, 4-2, 4-3, 4-4, 4-5. Okay, and then 5-1, 5-2, 5-3, 5-4, 5-5. Okay, let me double check to make sure I'm understanding this right. So it says that the player wins if the larger of the two numbers is greater than 5. Okay, the player wins if the larger of the two numbers is greater than 5. Okay, well, folks, what I did here, okay, these are not the winners, okay? This is for losing the game. Whoops. Okay, this is losing the game. Or you don't win. Okay, so I misread that at the beginning. So let me read it one more time, make sure. The player wins if the larger of the two numbers is greater than 5. Okay, so here you don't win. Well, where do you win? Okay, well, to win would be the rest of them. Okay, let's see if I can get these typed out. So, you know, and I want these to be a different color. So I'm going to go ahead and type these out, and I'm going to stop recording while I type these out. Okay, be right back, folks. Okay, so I typed out almost all of them. So to win, that would be like spinning a 1-6, a 1-7, a 1-8, a 1-9. Now this is 1-10. You see 1-1-0, that's 1-10. Okay, spinning a 1 and a 10. Okay, so if I count these up, ladies and gentlemen, I see that there are 25 ways to lose. And it looks like then there would be 75 ways to win. Now, I didn't finish the last row. Please note that it's ... So 10-1, 10-2, 10-3, and so on. So 75 ways. All right, so that is part B. What are the possible outcomes? Okay, so that's part B. C, describe a correspondence between the random digits from a random digit table and the outcomes in the table. Okay, so if we were going to use the random digit table, obviously 1 will represent 1, 2 will represent 2, 3 will represent 3, and so on, except 0 would represent 10 if we're using the table, okay? If we're using the table. So that's answer to part C. The correspondence between the random digit from a random digit table and the outcomes in the game. So 1 would be 1, 2 would be 2, 3 would be 3, 4 would be 4, and so on, except 0 would have to represent the 10. Simulate 20 repetitions. What is the estimated probability you will win the game? Well, we're going to use the calculator, not the table. So seed the calculator with 205. All right, so here we go. So I'm going to go ahead and seed the calculator with 205. 205, store, math, probability, rand. Okay, now I'm going to go ahead and go back to probability. Pick number 5. Now, since I'm using the calculator, folks, I'm just going to go ahead and use 1, 10, comma. Okay, now I have to play this one game at a time. One game at a time, which is 2 spins. So 2. All right, so enter. Okay, well, ladies and gentlemen, it looks like that is a win. Okay, I'm going to write win down. Win. And the next one is a loss. And the next one is a win. Okay, I'll do one more and then I'm going to pause and finish this. Then the next one, okay, is a lose. All right, I'm going to pause, finish it, you pause, and you finish it. See if we come up with the same answer. Hopefully I don't mess up. All right, so this is what I came up with, ladies and gentlemen. Hopefully your wins and losses match mine. So the question is, what is your chance of winning? Well, I came up with 13 wins out of 20. So my estimation is that you would win 65% of the time. All right? All right, let's do one more, okay? This one is really cool. I love this problem. I love this problem. All right. How many cereal boxes? I don't know if you know, I always buy the same cereal now, but when I was a kid, I was always excited when my mom bought cereal, especially the cereal boxes that had prizes in them. Oh, that was great. Okay, so I don't know if they still do that kind of stuff, but how many cereal boxes? You can get one of 6 prizes when you buy a box of cereal. You want to collect all 6 of them. How many boxes of cereal will you need to buy before you have all 6? Use the calculator, seed it with 200. All right, set up a simulation to do a minimum of 10 trials, okay? So I'm going to go ahead and type this out. So first of all, my assumptions. Okay, these are really important. 1. Okay, so we have to assume that we're going to stop after you get all 6. Let's see, does it say what kind of prizes it is? It doesn't look like it. So, nope, it doesn't say what type of prize it is. So, stop after you get all 6 prizes. 2. Assume, this is important, assume all prizes are randomly placed in each box. Now that's a far stretch because I think when they make them, they just stick a whole bunch of the same prizes in a box and then they switch to a different prize. So, but we need to assume all prizes are randomly placed in a box, or something like this, or the boxes are randomly shipped to stores. Okay, that might be a possibility too, but we have to, something about them being random. All right, so the question is, now I want to get you used to this notation, folks. So this is the question. So P stands for probability, and then inside of that we have parentheses. So what's the probability of getting each prize? okay? Well, the probability of getting each prize is 1 out of 6, okay? So that's the probability notation. Notation is going to be really important. Now, when we set up this simulation, folks, okay, so in the simulation, we're going to use number 1 through 6. Okay, you can't set it up any other way. So that means if we were using the random digit table, we would have to ignore or skip over the 7, 8, 9, and 0. Okay? So if we're using the table, if we would run into a 7, 8, 9, or 0, we would just have to skip over it. Okay? We would just skip over those. There's no other way to set it up to be any more efficient. But using the calculator is really helpful on this one. Okay, so I'm going to show you the process that this takes. Okay? I'm going to do 2 of these, and then I'm just going to go through and I'm going to give you what I came up with. So when I simulate this, what I'm going to do first is I'm going to write out, okay, so there's 6 prizes, right? So I'm going to make the numbers 1 through 6. 1, 2, 3, 4, 5, 6. Okay, so that's prizes 1 through 6. Now, when I use my calculator, and unfortunately I can't keep the calculator up there, so I'm going to be going back and forth a lot. So I'm going to demonstrate this with just 2 of the repetitions, okay? But first let me get my calculator set up. So I need to seed it, what did it say? With 200, and we're going to do 10 trials, okay, or 10 simulations. All right, so here we go. So again, we're going to seed it with 200, okay? Let me double check that one more time. Yep, 200. Okay, so 200. I'm going to store that into RAND. Okay, now, folks, you have to do one at a time. You buy one box, you check your prize. You buy another box, you check your prize. You buy another box, you check your prize. You can't buy a whole bunch in a row. One box at a time. So this simulation takes some time, okay? But you need to see this type of simulation. Now, with the calculator, I can say I only want 1 through 6. Okay, so here we go. This is how you need to do it, and this is time consuming. I'm going to demonstrate with 2 of these, and then you got 8 more to practice on. All right, here we go. So enter. Okay, I got prize number 1. So what I'm going to do is I'm going to cross that off and make a tally mark. Ooh, okay. So that was 1 box. Hit enter again. I got prize number 2. I'm going to cross it off. I'm going to make a tally mark. Okay, next prize. I got prize 1 again. Okay, well, I can't cross anything off, but I do need to make a tally mark. Hit enter again. Prize number 6, and I make a tally mark. Hit enter again. Prize number 3, cross it off, make a tally mark. Okay, next one. Prize number 6 again. Okay, well, I can't cross it off, but I do have to keep track. I bought a box, I make a tally mark. Hit enter again. Prize number 1. Okay. Tally mark. Prize number 3. Tally mark. Prize number 4. Or next prize, nope, 3 again. Tally mark. Okay, again, you have to buy 1 box of cereal at a time. 6 again, my goodness. Tally mark. Ah, prize number 4. Tally mark. Yay, prize number 5. tally mark. So in my first simulation here, folks, I had to buy 12 boxes. Woo, 12 boxes. Okay, let me demonstrate that one more time. So what I'm going to do is I'm going to go 1, 2, 3, 4, 5, 6. Okay, now I'm going to just keep going with my calculator. Don't reset anything or your answers won't match mine. Okay, so I'm just going to go ahead and hit enter. Prize number 4. Tally mark. Prize number 6. Cross it off, tally mark. Prize number 4 again. Okay, just a tally mark that time. Prize number 5, tally mark. Good. Prize number 2, tally mark. Prize number 6 again. Well, I can only put a tally mark for that one. Number 1, good. I cross that off. Number 1, tally mark. Prize number 2 again, just a tally mark. Hey, yay, all 3 tally marks. So that one only took 9 boxes of cereal to get all 6 prizes. Okay, so pause the video and do that. For the rest, it's going to take a little time. It might take you 5 to 10 minutes. Okay, I'm going to go ahead and pause what I'm recording and write down with what I came up. I'm not going to do all the tally marks. I'm just going to write down with what I came up. So I'll be right back. All right, folks, so this is what I came up with. So in my first one, 12 boxes. The second one was 9. The third one, 8 boxes. The fourth trial, 19 boxes. 13, 10, 17, 17, 19, and then the 10th trial I got 16. Okay, so the question is, how many boxes of cereal are you going to need to buy before you have all 6? So I'm going to find an average. So if I add all of them up, whoops, that's not the word add, that's the word all. Okay, add them up, divide by 10. Now, hopefully I didn't make any mistakes. They added up to 140 for me. Divide by 10, and I came up with 14 boxes. So on average, to get all 6 prizes, you're going to have to eat or buy. You're going to have to hopefully eat them too. You're going to have to buy 14 boxes on average to get all 6 prizes. Again, we're having to assume that they're randomly placing those prizes in the boxes, or that the boxes are being randomly shipped to stores. That one's probably more realistic because technically they're being randomly shipped to stores. They don't pick out, they just put boxes in there and send them to stores. All right, I love that problem. All right, folks, I think that video is long enough. Whew, I'll see you in class.